So our next speaker, Ian Billing with Teknique. I was saying earlier that all of these talks really resonate with me, having actually built systems, and in particular the idea of using a system on module to accelerate time to market and frankly reduce risk as well is, I think, just a huge step forward, especially given the complexity of computer vision systems. Ian brings, I think, 25 years of experience in both development and management of complex electronic systems, and love to hear what you have to say.
Okay, great. Now I'm really happy to be giving you my presentation on accelerating smart camera time to market using a system on modular approach. For my presentation, I'd like to start off by just explaining and going over a little bit about who we are as a company, what we do on a day-to-day basis, what we've done to get to the point of where we are today. And therein, having overcome many challenges along the road to embedding vision into our customers' products. And through overcoming those challenges, a lot of mitigating systems and methodologies that we've applied into the development process have now ended up in us internally using a system on modular approach to overcome the problems that we face internally. And now we're at the point that we're able to deliver a system on modular approach out to our customers in order for them to mitigate against very much the same challenges that we ourselves have come across over the last years. So just to go over who we are and what we do, we're Teknique Limited. We're an embedded vision development company based in Auckland, New Zealand. We have offices in Munich, in Germany, and we also have representation here in the United States of America. What we do is we create better ways to view and interpret and understand the world by integrating our smart camera platform technology into electronic products. We've been around since 2004. We leverage exclusively on the Ambarella chipsets, and over the last 15 years, we've become pretty expert and specialist in what we do on the Ambarella chipsets. And as the slide says, we have aided in putting more than 6 million cameras successfully into the market to date. We are the name behind many well-known products that are out there on the market today from an embedded vision perspective. What we do is we take the onerous impact of research and development off a customer's shoulders who are not embedded vision specialists, who are product specialists, who want embedded vision in their products, and we free up our customers' resources for their own strategic initiatives. We allow our customers to stick with what is their core strength, and which is enabled by us sticking to what is our core strength of taking care of the smart camera embedding part of those projects. We also operate on an OEM and an ODM basis where we've built specification or customized existing module design. And we have, in many cases, then delivered directly into our customer's supply chain and allowed them freedom to focus on delivering their benefits to their own users. Now, in this journey of 15 years, we've come across many, many challenges, and not much different from any regular development company that has done this. We find that by a traditional method, and what I mean by traditional method is a method that doesn't use a system on modular approach. It's very common, and the challenges are common. Typically, it's very costly, it's very time-consuming. Therein, there's collateral risks that come along. There's unique skill sets that are required, and you end up with an inevitable problem with economies of scale. If you take a look at the traditional process of prototyping, of iterative prototyping, and spinning up multi-layer circuit boards with high-speed signal tracing and going through the iterations of getting that to the point where you have something that you can build a prototype from, a proof of concept from. By the time you've gotten to the end of it, together with having gone through the iterations of your firmware library developments, it has become very costly. The discrete components in embedded vision also being more expensive than traditional electronic development also adds to the cost of your project. It's very time-consuming. Research and development processes take time. That iterative process takes time, and therein lies the big risk. How many potentially viable embedded camera technology products that would have been viable, that have overrun their project timelines, have actually been canned, that would have made it to market had it not been for the risk of cost and time. We found as well in this journey that the embedded vision development skills that are required from an engineering development point of view, coming to neural networks, etc., is far more complex. It's far a rarer skill to find out there on the market. It's difficult to find, it's difficult to source. Once you do source it, it's difficult to contract. Once you do contract it's difficult to retain it. So all in, there are the challenges. And these aren't by no means unique to us. At the end of the day, when you do have a proof of concept that you now have together that is satisfactory for your product that you want to embed your smart camera in, now you're working against economies of scale. We all want to build the cameras in the many, many thousands, and certainly that's the business aspect of it, but it's just not viable to do anything else other than that. So if you do have a product that would otherwise be viable in the hundreds or the lower quantities because of the amount of cost up to the point of proof of concept, it's just simply too expensive to run and roll out in smaller quantities. So these are the challenges that we've faced, and in our journey, we ourselves have implemented a system on module approach in order to get our own products into the market, or our customers' products into the market, has certainly assisted us. So what we've come up with is our product, which we refer to as Oclea. The Oclea is a development environment, a development kit, an EVK slash SDK. And with our development kit, which we call Oclea, which covers across a few different systems on modules, which I'll go over, it certainly does accelerate your smart camera time to market. Basically put, the system on module, the Oclea, it's an integrated camera module that enables device makers to streamline the development process, reducing development risk, cost, and time, and mitigating against those challenges. So there's a rendering of our one particular EVK that we do have, and all of this stuff that I'm showing you is also available on our stand at our booth outside here as well. You can choose a combination of lens and sensor to suit your application. We have the SoM integrated into the EVK, and we then have all the power supply and networking attached to that. The idea is that you take the EVK combined with our SDK, develop your proof of concept to a point at which you're happy to take that to market, and at that point you extract just the SoM out of it. This is our micro SoM. Our SoM comes in two form factors. This is the smaller form factor. We call it a micro SoM. You extract that SoM, put that into your own product, into your own form factor, and you can go to market with that. Another challenge that we've come across, which I'm sure anybody in the development environment over here will definitely have come across, is that it's a big leap between developing your proof of concept on your laboratory bench, where you're in control of the environment and it works perfectly, and then putting it out into the real world where you don't control the environment and things tend to, I won't use the word fall apart, but they do definitely tend to react a bit less than perfectly. That's it. Thank you, Paul. Thank you. So you can also put the EVK into our housing where you can actually then take your proof of concept out into the real world and you're able to then get real world feedback from it and adapt your design from there on forward. We have the standard EVK style of board. This is just by the way, these two pictures are of the identical board. They just rotated around 180 degrees. And the one has got our smaller form factor SoM on it. The other one has got the larger form factor SoM on it. At the moment, the underlying Ambarella socks that we have on our SoMs are in the smaller one, the S5L, and in the larger one, the CV22. And we'll continue to be developing these SoMs as time goes on. At this point, the difference is that the S5L is what you could call the entry level at a favorable price point SoM, and then CV22, it's a bit more got a bit more horsepower in it, and it brings a machine learning at the edge to the development party. That's the hardware. From a software point of view, taking a look at the software stack. At the heart of it is the Linux kernel. It's an embedded Linux kernel supplied by Ambarella that also takes care of all the DSP. We've built a bootloader on top of that, ready to accept your compiled image. So once you've done your own bespoke developments. On top of that, we have the Linux user space. We have got the GStreamer libraries. The software aspect of the development kit is based on GStreamer pipelines. I'll talk more about that in a moment. And for the SDK, we have developed GStreamer elements, which then abstracts and enables you to develop your application. We have then the GStreamer user space, which we'll also drill down into a little bit further in a moment. wherein you will write your own IP. Taking a look at a hardware block diagram of the S5L, the smaller one, but they all pretty much, the concept is the same, even if it's not specifically like this. We have here abstracted in the SOM, and this for me is in my experience, this for me is the beauty of what we've done here, is that we have abstracted the complexities of the underlying Ambarella layer completely so that it's very user-friendly, developer user-friendly for you to create and use your GStreamer pipelines. But as soon as a development engineer like myself hears the word abstract, I lose interest and say, oh, no. If you've abstracted everything, then I've got no access to the kernel, I've got no access to the operating system, I've got no access to use those stuff that worked for me really well before. But we haven't. We've only abstracted that aspect of the complex underlying layer, yet we have kept completely open your access to the Linux operating system and Linux user space. So you've got access to all the peripheral buses there, R2C, SPI, GPIOs, the UARTs. So you want to develop an application that through Linux, you've got your drivers that are tried and tested, you want to put Wi-Fi on it, do so. You want to have extra memory on an R2C bus, do so. You want to put triggering events into your camera with an external passive infrared that you want to control over GPIOs, do so. You don't have to do that through our abstracted layer. You still got the power to develop in that line over there, which I think is very, very valuable. On the breakouts, you have access to all of those points on the SOM as well. The power supply management, the regulation, the thermal considerations, all taken care of. The memory supply, the memory tuning, the memory configuration, that's all been taken care of. The TPM that we have there, that's been sorted out. So basically, all of the complexities and the challenges in getting to a point where you actually have a device that you can use for embedded vision has all been taken care of, literally, that you can actually take it out the box and start developing your application as opposed to start trying to create something on which you can develop your own application. Put the presentation together and somebody said, you're not really telling us where you are with this. Where is this to come? Has it been? So this fixes that. Okay, in the fourth quarter of 2018, we then launched in Europe the S5L, the EVK as a whole, and we actually started shipping in the first quarter of 2019. We have shipped our EVKs in Europe and in the States as well. Now here, as we speak at Embedded Vision in this quarter in 2019, we're launching the CV22 SOM. This is the larger form factor, and we'll be ready to start shipping these with the GStreamer SDK going into the third quarter of this year. And ahead from here on forwards, as Ambarella releases more devices, more SOCs that we can leverage off, we'll create more SOMs for them along the same architecture as what I have described over here. And right now, those two are doing very well for us. To talk a little bit about the software aspect of the development kit, the SDK, it is a GStreamer plugin. Why do we choose GStreamer? Because GStreamer it's ubiquitous. It's an open source framework. Any developer in embedded vision will know how to use it, how to work with it, has used it, has worked with it. It's easy out the box to start to get going, as opposed to having to learn something new. It's very easy to produce GStreamer pipelines. In our GStreamer elements, we've got video source there that you can call up a video source in short order. We include in our build a WebRTC component, as well as an Amazon KVS, Kinesis video stream element that's included in the build as well. Just to get back to our software stack over there with reference to the GStreamer plugin, we have the GStreamer libraries that are as part of the image that we flash in. We have our elements in the SDK, and then we've got the GStreamer user space. So you, the developer, take it out the box, get into your GStreamer user space, develop your own application, and drilling down into that GStreamer user space, your code, your C++ coding, your IP, your algorithms, your tried and tested models that now are valuable to you. You don't want to go and have to redevelop those into another system. You can use those in the GStreamer user space within our SDK. We provide the wherewithal, the components. We've got the libraries, we've got the compiler, we've got the tool chain, well, the compiler to work with the tool chain. We have the Docker scripts, and we have the OTA scripts for flashing to compile all of that into your image that then gets flashed into the EVK. So it's pretty simple, and it works really, really well. So taking a look at this dev kit from an out-the-box experience to doing something useful with it, which would usually be maybe months, as I'm sure all of you know. This over here is a very viable use case that from out the box to deployment you could do probably within a day, maybe a day and a half. Take your Oclea EVK out the box, call it a baby monitor, call it a security camera, call it a drone camera, call it a action camera, whatever you want. Put a trigger onto it, be it a passive infrared or be it by your own coding to pick up movement on the camera. Create a trigger. With that trigger, connect to our Oclea Web RTC signaling server, get a peer ID, use your mobile device, set up a stream directly to your camera. Something happened, there was a trigger, you can look directly at the camera. But wait, there's more. You can then go back X amount of time, 10 seconds, 20 seconds, and you can then upload that via Amazon Web Services and via the Kinesis element in there. You can upload that to Amazon Kinesis for semi-persistent data storage. And then on the back end there, if it's something that you wanted to persist for more than the time that you've set your Kinesis up for, then you can put it into an S3 bucket. So that's basically a very easy use case. And also with the support portal that we do have and the support personnel in the office that we do have, we're out there to support engineers in making this happen. So it is backed by a good support system. So in conclusion, using the Oclea development kit, the SoM, the EVK, the SDK, it lowers your time to market for embedding vision in your product. It lowers the risk of embedding vision in your product. It mitigates against the typical risks that we've come across, and I really know that you guys have all come across. It leverages the GStreamer framework and enables our customers to focus on their core strengths, doing what they do best, not having to worry about the embedded vision side of it. So just a bit of a summary of the resources over there. We do have data sheets for our two SoMs at our booth. It's on booth 613. It's the first one out here outside the door. There are some reference sites for you as well. Come talk to us at our booth. We'd love to talk to you about your projects. We do have a commercial component there. We have got developers there. So any questions that are put to me that I can't answer properly or completely, you're welcome to visit us over there. So everyone, thank you very much for your time. Greatly appreciated, and we hope you'll be using Oclea soon. Thank you.
So if you have any questions, please come up and use the microphone. And I'd like to start with a question, which is, can you tell us a little bit about some success stories where either you've done something where you've shipped a lot of volume using one of these SoMs, or perhaps you've averted disaster, right, by getting the customer from here's a project which was falling apart and flaming debris to actually
Phil,
using a SoM.
I've got such great stories to tell, but man, those non-disclosure agreements are a problem.
You can be vague.
Yeah, we have. I think averting disaster is without naming any specifics. Yeah, we've had real-world cases where very well-known big companies have gone a long way down the road, and they are not embedded vision companies. They do what they do well, but they don't do embedded vision. They had a development component in-house. They went down the road. It didn't work out. Now they were in big trouble, and we've actually applied and we're doing one right now as we speak, which I can't speak about, but where it has actually saved the day that they've been able to take the SoM out the box and carry on their original roadmap, which fits in with the original timelines. So yeah, very much so.
Yes, sir. Can you talk a little bit about what plugins are available, particularly about neural network inference and detection?
I beg your pardon, I didn't hear the question.
Can you talk about what GStreamer plugins are available? Particularly about neural network detection of people, faces, things like that.
Yes,
performance.
I got it, certainly. We do have a few plugins at the moment with the EVK that we provide the video sources. As far as the neural networks are concerned, we apply it by means of GStreamer filters, and we are busy in development with that right now. The CV22, in which, with the hardware acceleration of the neural networks, is what we're dealing with now, applying filters to those GStreamer plugins, and we're right in the process of launching that right now by means of filters. Yes, we do. At our stand at booth number 613, we have a demo up there of exactly that on the CV22. Thank you very much. Thank you.
So, based on your experience, could you please share some insight on motion blur, or how do you mitigate that in your end customers' applications?
I beg your pardon, mitigating against?
Motion blur.
Against motion blur?
Yes.
That's a very good question, and it's a question for our engineers that I'm sure they'll give you more information on if you visit us at our booth. Thank you very much.
Any other questions? Great. Well, Ian, thank you very much.